The National Electrical Code, or NEC, does not explicitly prohibit connecting a 220-volt rated appliance to a 208-volt circuit. However, there are several factors that will lead an inspector to reject such an installation. These are based on general safety principles and specific code requirements. The inspector may have been referring to NEC section 210.9b2, which states that equipment shall be connected to circuits of the correct voltage and frequency. Consider the implications of this rule in the context of a 220-volt appliance connected to a 208-volt supply. A 220-volt coffee brewer, for example, is designed to operate at 220 volts. A 208-volt circuit can only supply 208 volts, which is less than the appliance's rated voltage. This voltage difference can lead to several issues. Firstly, the appliance may not function as intended. It could heat up slower, brew weaker coffee, or not operate at all. Secondly, the reduced voltage can cause the appliance to draw more current to compensate, potentially overloading the circuit. Thirdly, operating an appliance outside of its designed voltage range can damage its components and shorten its lifespan. The NEC also requires that conductors have an ampacity not less than the maximum load to be served. This requirement is detailed in NEC section 210.19a. For a 220-volt coffee brewer drawing 30 amps, the circuit conductors must be rated to handle at least 30 amps continuously. Connecting this appliance to a 208-volt circuit can create a situation where the actual current draw exceeds the circuit's capacity, even if the breaker is rated at 30 amps. This is because the appliance will try to draw more current to achieve its intended power output at the lower voltage. Overcurrent can lead to overheating of the conductors, insulation damage, and potentially a fire hazard. A standard 30-amp circuit is designed to safely handle a specific amount of power, calculated as voltage multiplied by amperage. When the voltage is reduced, the amperage increases to compensate for the power difference, potentially exceeding the circuit's design limits. In addition to the voltage and ampacity considerations, there may be other factors influencing the inspector's decision. The specific design and characteristics of the appliance in question can play a role. Some appliances are more tolerant to voltage variations than others, but this is not a guaranteed characteristic. It is essential to consult the appliance's nameplate and manufacturer's specifications to determine its acceptable operating voltage range. Furthermore, the electrical system's overall capacity and load calculations must be considered. Connecting a 220-volt appliance to a 208-volt circuit may negatively impact the system's ability to handle other loads. This is particularly important in commercial or industrial settings where multiple appliances and equipment are operating simultaneously. The NEC provides guidelines for calculating the total load on a circuit and ensuring that the system has adequate capacity to meet the demand. If the addition of the 220-volt appliance would cause the system to exceed its capacity, the installation would not be in compliance with the code. In summary, while the NEC does not explicitly state that a 220-volt appliance cannot be connected to a 208-volt circuit, the requirements related to voltage, ampacity, and overall system capacity effectively prohibit such installations in most cases. The inspector was likely applying these principles to ensure the safety and proper functioning of the electrical system. To further elaborate on the technical aspects, let's consider the concept of impedance. Every electrical device has an impedance, which is the total opposition to the flow of alternating current. Impedance is a combination of resistance and reactance. When a 220-volt appliance is connected to a 208-volt circuit, the impedance remains the same, but the voltage is lower. According to Ohm's law, current is equal to voltage divided by impedance. Therefore, if the voltage decreases and the impedance remains constant, the current will also decrease. However, many appliances are designed to deliver a specific amount of power, which is calculated as voltage multiplied by current. If the voltage is lower, the appliance will attempt to draw more current to maintain the same power output. This increased current can overload the circuit conductors and the appliance's internal components. Moreover, the frequency of the electrical supply is also a critical factor. In the United States, the standard frequency is 60 Hz. NEC Section 210.9b2 requires that equipment be connected to circuits of the correct voltage and frequency. If the frequency of the 208-volt circuit is different from the required frequency of the 220-volt appliance, it can cause the appliance to malfunction or become damaged. While it is unlikely that a 208-volt circuit would have a different frequency than a 220-volt circuit in the United States, it is still an important consideration. In addition to these technical factors, there are also practical considerations. Connecting a 220-volt appliance to a 208-volt circuit may void the appliance's warranty. Manufacturers typically specify the acceptable operating voltage range for their products, and operating an appliance outside of this range can invalidate the warranty. Furthermore, it may be difficult to find replacement parts for an appliance that has been damaged due to being operated at the wrong voltage. The inspector's decision to reject the installation was likely based on a combination of these factors. While it may be technically possible to connect a 220-volt appliance to a 208-volt circuit, it is generally not recommended due to the potential safety hazards and performance issues. The best solution is to use an appliance that is specifically designed to operate at 208 volts or to install a 220-volt circuit if one is not already available. To further illustrate the concept, let's use an example calculation. Suppose a 220-volt coffee brewer has a power rating of 1500 watts. Using the formula power equals voltage times current, we can calculate the current draw at 220 volts. Current equals power divided by voltage, which is 1500 watts divided by 220 volts, resulting in approximately 6.8 amps. Now, let's calculate the current draw if the same coffee brewer is connected to a 208-volt circuit. Using the same formula, current equals power divided by voltage, which is 1500 watts divided by 208 volts, resulting in approximately 7.2 amps. As you can see, the current draw is higher at 208 volts compared to 220 volts. Although the difference may seem small, it can still be significant, especially if the circuit is already loaded with other appliances or equipment. This increase in current can cause the circuit breaker to trip or the conductors to overheat. Therefore, it is important to ensure that the circuit is properly sized to handle the increased current draw. In addition to the current draw, it is also important to consider the voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. The longer the conductor and the higher the current, the greater the voltage drop. Excessive voltage drop can cause appliances to operate inefficiently or malfunction. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. It is important to calculate the voltage drop for the circuit to ensure that it is within the allowable limits. The voltage drop can be calculated using the following formula: voltage drop equals 2 times the current times the length of the conductor times the resistance per unit length. The resistance per unit length depends on the size and material of the conductor. The NEC provides tables that list the resistance per unit length for various types of conductors. To minimize voltage drop, it is important to use conductors that are large enough to handle the current and to keep the conductor length as short as possible. In conclusion, connecting a 220-volt appliance to a 208-volt circuit is generally not recommended due to the potential safety hazards and performance issues. The NEC requires that equipment be connected to circuits of the correct voltage and frequency and that conductors have an ampacity not less than the maximum load to be served. Connecting a 220-volt appliance to a 208-volt circuit can violate these requirements and create a dangerous situation. It is always best to consult with a qualified electrician to ensure that the electrical system is properly designed and installed. They can assess the situation and recommend the best course of action. They can also perform load calculations and voltage drop calculations to ensure that the circuit is properly sized to handle the load. Remember, safety should always be the top priority when working with electricity. If you are not comfortable working with electricity, it is best to leave it to the professionals. The consequences of making a mistake can be severe.